2x squared is equal to 9x minus 4. X is not equal to 4. What is the value of 2x? 2x squared is equal to 9x minus 4. Put everything on one side. 2x squared minus 9x plus 4 is equal to 0. And I think this factors. We won't need to use a quadratic, hopefully. And I think it is 4, 1, negative, negative. So that means that 2x is equal to 1, therefore x is a half, or x is equal to 4. But they told us that x is not equal to 4. So this is the only solution. And they want the value of 2x. So 2x would be 2 times a half, which is equal to 1. So number 10, the answer is B. When 3 plus 2x plus x squared times 1 plus mx plus m squared x squared is expanded and fully simplified, the coefficient of x squared is equal to 1. What is the sum of all possible values of m? Let's do that expansion, and let's see what we get. All right, so here we go. So we got 3 plus 3mx plus 3m squared x squared plus 2x plus 2mx squared plus 2m squared x cubed plus x squared plus mx cubed plus m squared x to the power of 4. All I need to care about is the coefficient in front of x squared. So that's the only thing I really need to care. Let's see here. What is the coefficient in front of x squared? From here, I get a 3m squared. From here, I get a 2m. And any others? Yeah, from here, I just get a 1. That's the only thing I need to worry about. And they're telling me that coefficient is equal to 1. So 3m squared plus 2m plus 1 is equal to 1. So that means 3m squared plus 2m is equal to 0. Factor out the m. I get 3m plus 2 is equal to 0. So that means m is either equal to 0 or 3m plus 2 is equal to 0. That would mean that m would be equal to minus 2 over 3. So the sum of all possible values of m, here's one value, here's another value. When I add those up, I get negative 2 over 3. So number 19, the answer is B. Alex chose positive integers a, b, c, d, e, f and completely multiplied out the polynomial product. After she simplified her result, she discarded any term involving x to any power larger than 6 and was astonished to see that what was left was 1 minus 2x. If a is greater than d plus e plus f, and b is greater than c plus d, and e is greater than c, what value of a did she choose? The first thing in this question is to try to simplify this, and we do that by noticing that there are certain algebraic identities that we can utilize. And these algebraic identities are used to simplify this into a slightly better form as follows. And I encourage you to go through these steps and figure out how we went from the initial given equation all the way to the bottom, which is right here. Basically, you take these algebraic identities and start subbing them in and then collecting like terms, and you will be able to get to this final step. This final step, the simplified version, is what we are going to work with, but we are going to make a few substitutions. This exponent we are going to call a, big A. So a will be a minus d minus e minus f. This exponent we are going to call b. So big B will be equal to b minus c minus d. And in a very similar way, that exponent we will call c, big C, will be e minus little c. And then big D we will call little d. And then just to be consistent, we will call the next one e, and the last one we will call f. Okay, so that means that this equation basically boils down to the following. It becomes 1 minus x to the a, 1 plus x to the b, 1 minus x cubed to the c, 1 minus x to the fourth to the d, 1 minus x to the fifth to the e, and finally 1 minus x to the sixth to the f. Okay? So at this point, we have to use binomial theorem to expand this. But the good news is that because we are initially going to be looking at values of x squared, because remember, this polynomial, when fully expanded, does not have anything of the form x squared, x3, x4, x5, or x6. So first, we are going to try to concentrate on the fact that there's no x squared when this whole thing is expanded out. So when we expand this using the binomial theorem, we initially only need to do it for the first two terms, because those two terms will give us an x squared, and all of these others won't. So that's why we only have to look at those first two. So first, let's talk a little bit about the binomial theorem. What is its general look? This is the general way that it would expand something using the binomial theorem. If it's 1 plus y, it would look like this. If it's 1 minus y, it would look like this. And the good news is that you only have to concentrate on the first few terms in order to get a x squared. So we will do that on this one right here. And there is our expansion. And we are only considering that we have to look at the x squared. So when you first did the expansion, it looks like this, right? But then when you simplify, it basically just boils down to this when you collect like terms. So the coefficient of x squared is just this guy right here. So that is what we will concentrate on. Now, since there is a term minus 2x and no x squared term in the full expansion, what that basically means is that this is equivalent to minus 2x. So minus a minus b x is equal to minus 2x. So that means a minus b must be equal to 2. And then this whole thing has got to be equal to 0 because there's no x squared term. So that means this, if you multiply it out, it becomes a squared minus a plus b squared minus b minus 2ab is equal to 0. I just multiply through by 2. If you factor this, you can do that. It becomes a minus b squared. And you can put the a and b on the other side. Now, a minus b is 2. So that means a plus b is equal to 2 squared, which is 4. So now I've got a minus b is equal to 2. A plus b is equal to 4. So I can add them. If I add them, I get 2a is equal to 6, and therefore a is 3. So that is my first letter that I have solved. And this one will quickly give me a value for b. B is going to be equal to 1. So I've got a and b so far. And in a very similar way, we're going to get the numerical values for C, D, E, and F. So now that we know a is 3 and b is 1, our polynomial now becomes 1 minus x cubed, 1 plus x to the power of 1. And then all the other ones we still don't know because we have not figured out those letters yet. But we can expand this out since we know these. And when you do, you get the following. 1 minus 2x plus 2x cubed minus x to the power of 4. and the rest remains the same. As we discussed before, we also have no x to the power of 3 in the full expansion. So that means that this x to the power of 3 must eventually cancel somewhere. And that minus 2x to the power of 3, that will cancel the positive 2x to the power of 3, that's got to come from this guy right here, because that's the only one that has x to the power of 3 in it. And therefore, we have to again use the binomial theorem to expand this, but we only have to do it in a way that we get the very first two terms. And if you do it, you will clearly see that the expression becomes 1 minus cx to the third. So that means this minus cx to the third has to be equal to minus 2x to the third in order for that to cancel with this guy, which appears right here. Because remember, the question says that when you do the full expansion, there is no x to the power of 3 term. So this basically means that c is equal to 2. So now we've got another one of those variables. Now, since c is equal to 2, that means my polynomial now becomes, and when you expand it, this is what the polynomial looks like at this point of our question. Now we continue in the very similar way. We have also been told that there's no x to the fourth, x to the fifth, and x to the sixth. And those are the ones that will help us solve for D, E, and F. So there is no x to the fourth in the full expansion, so we have to cancel this 3x to the fourth with a minus 3x to the fourth. And that minus 3x to the fourth has to come from 1 minus x to the fourth to the power of d, because that's the only term that has x to the fourth in it. So again, use the binomial theorem to expand this. And you only need to expand just so you get the first two terms, and that will easily show you that this must be equal to the minus 3x to the fourth. So minus dx to the fourth must be equal to minus 3x to the fourth, and therefore d is equal to 3. So now I have got another variable. So if d is equal to 3, my equation now becomes this right here, which I obtained by putting d equal to 3. Now at this point, again, we have to continue in the same way. We know that there is no x to the 5. So to cancel this 6x to the 5 that I have figured out, there has to be a minus 6x to the 5 that comes from here. And as before, we use the binomial theorem to expand this. And when you do, you get 1 minus ex to the fifth plus ... But we don't need to go any further. We just know that this has to be minus 6x to the 5. So that means minus ex to the 5 has got to be minus 6x to the 5, and therefore e is equal to 6. So I've got the second last one, and therefore as e is equal to 6, my expression now becomes equal to this. So at this point, we have just one letter remaining to solve. And by this point, hopefully you get the hang of this, that there's no x to the sixth. So this 9x to the sixth must be canceled by a negative 9x to the sixth. That's got to come from there. So, as always, with this question, we have to use the binomial theorem to expand. And when we do, we get 1 minus fx plus ... And then this, therefore, has to be 9x to the sixth. So minus fx to the sixth has to be equal to 9x to the sixth. Therefore, it had to be negative 9x to the sixth. That's what we need to cancel. So therefore, f is equal to 9. So there we go. We've gotten all the letters. And I will summarize all those letters. A we got as 3, B is 1, C is 2, D is 3, E is 6, and F is 9. Now recall, those were the big ones. We had made substitutions earlier. We had made the substitution that big A is equal to small a minus small d minus e minus f. That big B was equal to b minus c minus d. C was equal to small e minus small c. D was equal to just small d. E was equal to f, small f, and big F was equal to small c. So we can quickly get these. Some of these are pretty easy. C, therefore, is going to be equal to F, this small c, A, B, C, D, E, F, these small letters. C is equal to F. Well, F is 9. So there we go. E is equal to F. So this small f is the same as big E. And then big D is equal to small d. So D is equal to 3. Now let's figure out E, B, and therefore A, where A is the one that the question is asking for. Well, from this equation right here, big C is equal to E minus C. Well, big C is 2. So 2 is equal to E minus C. And C, small c, is 9. So therefore, small e is 11. And then from this equation right here, our big A is equal to A minus D minus E minus F. Our big A is 3. A is what we're trying to figure out. Small d is 3. Small e is 11. Small f is 6. So therefore, A is equal to 3 plus 20. And therefore, A is 23. And that is the answer to the question. So number 25, the answer is E.